Hello guys, welcome back. In this video, let us understood how to generate our analysis related dashboards by using a TensorBoard. If you are training a ML model, then we will perform validation of our model while training, right? Yes. So after validating the result, storing the logs and visualizing that whole data like this in a visualized interactive manner by using a TensorBoard. So how to do this? How can we able to visualize the logs? How to store the logs while training and validating our ML model, and how to visualize those logs after storing the logs? How to visualize those logs by using this TensorBoard? So that we will understood in this video. I'm just reloading this. Yeah, you can see now this is not there. I'm just closing the site. Okay, now I want to open, yeah, this is the playground, or you can say this is already image classification related code. Now inside this we need to write these commands. Okay, I'll tell you, and we also mention this callback as well. Okay, so first we need to store the logs inside a folder, inside any one of the folder. So while training we need to create a dictionary to store the logs. So how can we able to create that dictionary? So here we need to specify callback. Here we need to specify, while training we need to specify callbacks. So in this we need to provide our TensorFlow callback. So what is this TensorFlow callback, sir? This TensorFlow callback is nothing but it specifies your TensorFlow dashboard, that where your output files are stored. So let's mention that in this variable TensorFlow underscore callback. Yes. So in this we need to mention callbacks for TensorFlow or TensorBoard by specifying where our logs need to store, in which log directory we are expecting to store the logs. So currently, previously I stored my logs while testing. In this, you can see how the logs will be stored at the end. Now I want to create one more folder like this in order to show you. So log1 hyphen spit. So like this, inside this I want to store the logs. Then we also need to specify the frequency of histogram, so that we can able to visualize the histogram as well. That is in each epoch cycle how the biasing will be. So those concepts also we can able to understood if we mention this. Now I'm expecting to run this. So that what happens is, so first let me run this and then I'll explain. Now what happens is, so this actually this code is for image classification. While creating our model, it will create this callback. That is, it will create this log directory where after yeah, we need to import this callbacks from TensorFlow. We need to import this callbacks from TensorFlow.keras. I'm importing these callbacks. Then we need to run it. Okay, I think hope right now we can't get, no more errors are there. So that's why it is running. So now what happens is, while training our model, this callback tensors dashboard related logs will be stored in this folder or in this location. So that folder will be created at the end after all epoch cycles, and those related logs related to training as well as testing. You can see this is the sample thing, like a training folder as well as validation folder related logs will be created in this way at the end of all epoch cycles. By using that data, we can able to visualize that data in TensorBoard. So that also will understood after finishing all the epoch cycles. Currently I mentioned, or I trained my model for 10 epoch cycles. After the 10 epoch cycles, I'll again play the video. You can see totally I mentioned 10 epoch cycles. Currently log1 folder is created. Inside this training related data is logs are stored in this, and validation related logs are storing in this. After all 10 epoch cycles, our model related all logs will be stored in these. Then after we can able to use this TensorBoard to visualize the data. Now you can see this is the last epoch cycle. That means our model is getting trained with all epoch cycles with the training data, and yeah, we'll also get the output here. if we elongate it, then we can able to see the results like what is the image. Since it's related to image classification and it detected the image, the predicted label is cat. Okay, so like this, our model got trained and it is working. Okay, then if you observe here in this log1 fit folder, actually our training and validation related logs are present, right? Yes. So we successfully created or stored our logs. Now, what is our task? We want to visualize or we want to see that data in a graphical manner in TensorBoard. Then how to do that? So in order to do that, you need to write the command that is a TensorBoard and hyphen log directory, log dir. You need to specify log dir is equal to. So what is the log dir? That is a log1 / fit. Inside this, our log directory is there. I'm just clicking on enter. Now it will generate you a local hosted dashboard. By using that local host dashboard, you can able to visualize these all logs, whatever the logs that are generated while training for this training as well as this validation logs. Those all you can able to visualize. I'm just clicking on it. Now you can see our tensor board is appeared. Now in this, if you observe, we have this scalars option. Here we can able to visualize scalars like loss as well as accuracy. You can see accuracy is visualized as well as the learning rate is constant, and loss, if you just click on it, it will expand. So the loss also will be visualized, and the comparison related to accuracy with each iteration is also visualized. You can see the accuracy is going on increasing, and the loss with respect to the iterations also visualized. You can see the loss is getting reducing, right? Yes. And not only this, here if you compare the loss as well as the accuracy, if you compare, then you can able to understood or detect the overfitting or underfitting those events where it is happening, and you can able to monitor the training process as well as compare the runs as well. Now if you see this graph, inside this graph, so I'm just changing the tag to Keras so that the Keras related main graph will be shown to us. Here you can see plus sign is visible. I'm just clicking on it, double clicking on it, so that whatever the flow is there related to my whole code, my whole model, so that is visible here. Here an input layer is there. If you click on it, that input layer related details like what is the input type as well as that related detail is visible here. And after taking the input, what we are doing, convolutional 2D matrix we are performing, that is visible. After that we are performing max polling action. Then after we are performing convolutional 2D. Then after we are applying this layer, that is a max polling layer. Then after we are applying again convolutional 2D layer. Then after we are flattening and we are applying a dense layer. At last we are also applying one more dense layer. So this is the process, like a top level overview of a graph related to our model. So here we can able to analyze the things like a model debugging as well as a performance optimization, like we can able to check redundant operations or suboptimal architecture designs, and we can able to understood complex models as well here in very easy way in this graph format. Okay, then we have histograms option. In this we can able to visualize, you can see we can able to visualize the distribution of weights, biases as well as the kernel across the training steps. Across each and every training step we can able to visualize this data like biasing data, and kernel data is visible right now. Here we can able to analyze the things like weight initialization, validation as well as vanishing gradients and model coverage. So these things we can able to visualize in this histogram. And we have this distributions. So what is this distributions, sir? This distributions will actually provide you more detailed view of this histogram data for exploring the outlines. So it is useful for gradient flow, like you can able to check the gradient distribution across each and every layer. So how many layers are there, in those layers how the gradient is distributed, and optimizer tracking, like you can able to observe parameter distribution over training steps, so that you can able to visualize here. So these are the things that you can able to visualize in this tensor dashboard effectively. If you open this time series, then it will show you again the bias related visualization, as well as each epoch cycle related accuracy, and each epoch cycle related accuracy related to each iteration. The overall dashboard is visible here in the front page as well. So like this, in this Tensor board, you can able to visualize your logs while training based on different matrices in a visual interactive manner in this Tensor board. And you can able to compare the training as well as the validation data set as well here based on the logs that are generated. If you want to stop this, website or this local hosting, you just click on Control C. Now I'm just clicking on Control C. Yeah, you can see it's got stopped. And if you open the page and if you reload this, then yeah, you can see now the site is not there, so we cannot able to reach that site. So that's it. Very simple. In this way, you can able to analyze and visualize interactive related dashboards while training as well as validation logs in Tensor board. I hope you understood how to store the log related data of training as well as validation data sets by just providing these changes. Like you just need to include these lines, that is you just need to include this callbacks inside your model training, and then you can just use the command that is this tensor dashboard and log directory you need to provide where our logs are stored. Then it will provide you the URL for, that is a hosted URL, in order to visualize the data set. I hope this video is useful and you understood the concept of how to store the logs and visualize the logs interactively in this Tensor dashboard. Hope this video is useful for while training your ML models and understanding the training data like accuracies and loss. So those related data like accuracy matrices related data, you can able to visualize in this Tensor dashboard while training your ML related models. Hope you get the knowledge of it, and thanks for watching. See you back in the next video with another interesting topic. Until then, bye bye guys. If you like the video, then please like it. Don't forget to hit the subscribe button and don't forget to like it. So please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye.